Hi everyone, welcome to our video on Dockerizing a Node.js application. I'm Wing and I've been working on documentation and
And I'm the lead developer on the projects, responsible for application code and Docker implementation.
so in this project we call Exploring Docker. Our aim was to leverage the power of Docker containerization and orchestration to significantly enhance the deployment process, scalability, and overall resilience of our Node.js application. We will show you how we use Docker and Docker Swarm to achieve this, creating a more robust, easily manageable, and highly available system. So let's get started with the backend Docker file. So it's concise but powerful. We use the Node 16 base image, set the working directory, and copy in JSON first for caching efficiently, and then we install dependency with the npm install. Copy the rest of the code, expose port 3000, and set the startup command to npm start, simple but effective. So let's move on to the Dockerify of front end. So now this is Dockerify is a little bit of complex, but utilizing a multi-stage build. The first stage, named build, start with from node 16 as build. Just like the backend, we use Node.js 16 to build our React application. We also set the working directory to app. Similar to the backend, we copy only package file, then run the npm CI, which is preferred in CI environments for clean install of dependencies. Next, we copy the environment file and then remaining project file. Run npm run builds is command that create the optimized production build on our React application. This is a set of static file that will actually be served to our users. The second stage of our multi-stage build is where things get interesting and efficient. We switch to a different base image from Nginx Alpine. Nginx is a lightweight, high-performance web server ideal for serving static content. Alpine is a minimal distribution, which makes the final image even smaller. Uh, from our front end, we built with React. It's served by Nginx. Nginx is a highly performant web server that efficiently serves static content and is perfect for serving a React app. It acts as both a server reverse proxy, directing traffic to the correct place, and a static file server, delivering the file that make our web app. And then if we have custom configuration for Nginx, the expose 80 tell Docker port 80 and CMD and daemon off start our Nginx server when the container runs. Now with the individual services load, let's see how they are orchestrated together. This is where Docker Compose come in. Okay, this file defines all our services, front, backend, MongoDB, and Redis. We specify the build context and make name for our front end and backend services. Importantly, notice the replica setting of the deploy. Replica is the key scale of our services. The Docker Swarm, this setting create multiple instances of our services, distributing the load and providing redundancy. That depends on configuration. Backend is crucial. It ensures that the MongoDB and Redis are fully started before the backend container tries to connect to them, preventing connection error during startup. The environment section allows us to configure our services by passing in environment variables. And for all that, we use the official Mongo image, the volume sections define and name volumes, Mongo data, which persists the database data, even if the MongoDB container is removed, with both the standard MongoDB port. We are using Redis Alpine, which gives us a Redis in a lightweight Alpine Linux container and exposing the standard Redis port. When we define app network, which use the overlay driver, allowing container to communicate seamlessly across multiple hosts if needed. So let's so this is a so next up is a demo section of Go.
Okay, thank you, Wayne. Today we will dive into deploying a full stack application using Docker Swarm. This application featured React frontend and the Node.js backend with Redis and MongoDB for data management and caching. We will deploy the app using Docker Swarm to enable load balance, ensure high availability, and test auto scaling. I will talk you through each step so you can follow along easily. Are you ready? First thing, we must clone the folder. If you don't have it in your computer, yes, choose the place where you want to play it. I will place it in the downloads and not open this page. Okay. Now you will see that we are in the project folder unnecessary called file. You'll see this. Okay. This, yeah. This involves front-end and back-end code, as well as the configuration file for Docker. Oh, sorry. Here for we don't. You can see that the front-end, back-end calls, and their configuration for Docker. Let's move on to the setting of Docker's Swarm. The Docker Swarm, if you're not familiar, Docker Swarm is a built-in operation tool for Docker that allows us to manage cluster of Docker container as the single system. This makes it perfect for deploying and managing multi-container application like Node.js container. On the thing we must do is type the command Docker Swarm. Okay, that's why I need to start. Okay. The next step is build a Docker image from the Docker compose file. You must learn the command Docker compose view. Okay, it will get the command from the Docker compose does which we talked about before. Build a container, building the image. Sorry. After that, we deploys using the Docker Swarm. To deploy, we run the Docker stack to create a stack and deploy. So minus C. C stands for the compose file. And we name the Docker compose file here. Docker compose. Sorry. And we can name this stack L1 to 1 in this situation. And we'll name it as online. For this, you will see this first thing. The Docker Swarm is a creating a network online shop app network. And after that, it creating the service like online shop Redis, front end, back end, and mobile. Okay, next thing we want to check is okay on here the Redis container, Mongo, and front end, back end in this Redica. So after that, we check it in. Okay. Okay. Test user one. And the password will be password one. Okay. So what is the result in this session? This is the server decoupling. We not have the database for the card, but we can handle the card or the customer from many account using Redis. Here we just have the products database. We just have the products collection, user collection, and the online shop database. You can see it. We do not have the Redis the card database. Okay. Hopefully, not, not, no. Okay, it's here. Now, the card will be two product. Let's deep dive into the Redis shop, Redis for the shopping cart decoupling. In this application, Redis play an important role in managing shopping cart data and effectively decoupling in the MongoDB. Here, how it works. The Redis store the temporary data for its user shopping cart. When the user adds the item to their cart, Redis handle this data weekly and store it in the temporarily and reducing the load on the MongoDB. Actually, it improves the speed of the user interaction. Only when user finalize their purchase in this data transfer realm, MongoDB for a long-term store. This strategy improves the response time and the system efficiency. Yeah, especially under the high traffic conditions. Um, now let's move on to the load balancing and auto scaling for backend. So let's move on to the next step, load balancing and auto scaling for backend test. Once a Docker Swarm greatest feature is load balancing. This automatically distributes the income requests across multiple replicas of a service, like our backend, which have keep response time low and ensure its replica only handle a portion of the traffic. So you can see here, there is one, two, three replica of the backend container. What's it this for? When you can you can see the script in simulator like 10 requests from the client to the server at a time. You can see the server with a config test role for with one the container. Actually, it's the ID. Okay, we run this for okay, open it to set run. Here we have we have three container, right? Here the first request go to the first container, another like commit the first, second, third, first, second, third. The last one is the first container. That's why I'm using the railroading return for distribute the incoming request to replicas our backend. Working through a remote service setup taught me so much more. I had to figure out how to connect the service, like the front end and back end, Redis, and MongoDB. I learned the hard way that Docker's network, like bridge and overlay, really mattered for getting everything to talk to each other properly. It basically multiple replicas, setting up balancing, and experiment with scaling was also eye opening. I also learned a lot about logging and monitoring with mm, using Docker build log to debug problem overall. This project gave me practical skills in managing and scaling container application that I will definitely carry forward in the real world projects in future. Thank you. So, me, what did you learn in this project?
Well, this project was a fantastic learning experience. We gained a practical hands-on skill with Docker, from building images with Dockerfile to orchestrating complex interaction with Docker Compose and scaling our application with Docker Swarm. We deepened our understanding of containerization and its advantages, especially for ensuring consistency across different environments, a huge benefit for development and deployment. Troubleshooting network issues and configuration challenges within a Docker environment honed our problem-solving skills, which are invaluable for any software developer. Beyond the technical skills, we strengthened our teamwork and collaboration. learning how to effectively communicate and work together toward a common goal in technical project. We are incredibly grateful for this opportunity to explore Docker and its ecosystem. We believe these skills will be essential for our future careers in software development. Thank you for watching our video. We hope you found our demonstration of this Dockerized e-commerce application informative and engaging. We're excited to continue learning and working with Docker in the future projects. Thank you.
Okay. Thank you.